So, when we think about innovation and technology, there's something that quickly comes up to our mind. Well, in the world that we are living in presently, technology is developing at a really fast pace. And believe me, we have no control over this. All of us are trying to create new ideas and new innovations based on the same. And we all do believe that education is the foundation of our economy. What we learn in school and how we learn it truly determines of who exactly we are, as we are global citizens now. And how successful we become in life is also determined by the same. It also shows how we solve problems, how well we work with others, and also how we look at the world around us. In today's innovative economy, education becomes even more important for developing the next generation of leaders, innovators, and creative thinkers. So without further ado, I would like to introduce our keynote speaker, Mr. Raed Hijer, who will talk to us about the same. Mr. Raed is a senior principal client technologist at Dell Technologies with over 20 years of experience in product development and leading engineering teams. Mr. Raed has an in-depth knowledge of GPU-accelerated VDI and cognitive technologies. He's also an expert in artificial intelligence and machine learning. So please join me in welcoming Mr. Raed to GISA 2019.
Yeah. Good morning, everybody. How are you? So, when I was asked to give this talk for AI, machine learning, and deep learning, and how it's affecting the future of our work, it's really an honor to be here and to talk about these technologies. But to be honest with you, this kind of talk is kind of hard to give because typically the audience will be more technical or like data scientists, and we're deep dive and Python codes. Now, before anybody moves or leave the room, don't worry, there's no going to be any Python codes or any of that deep dive. So, again, like I said earlier, talk about emerging technologies, how they're changing the future of work. So, artificial intelligence, machine learning, and deep learning. So, probably from now on, I'm going to refer to them as AI, ML, and DL for short. The gap between human and machine is shrinking. Okay? The difference between physical objects and bits and bytes is blurring, right? So a new era of human-machine alliances is on the horizon. So how do we benefit? How do we capitalize on this partnership between human and machine? So to answer this question, Dell has partnered with Institute of the Future to generate a report that shows there are 3 shifts that affecting or shaping the future of work. 67% of the respondents, those the business execs and the leaders, says technologies, AI technology more specifically, will be embedded into the hiring process to make sure that's inclusive talents in the workplace. 86% of those leaders believe also that AI will be used to increase the productivity and empower workers. And 70% also believe that AI and machine learning and deep learning will be necessary to augment and fill in the shortcomings of the workers. But how is that done? Why is this everybody talking about AI, specifically in more recent years? All starts with data, right? We, as humans, love to generate data. 500 million tweets a day, right? Not to mention the hundreds of thousands of images and videos being uploaded and downloaded every day. And the social media, of course. But also go into the enterprise, the corporate and businesses, right? So both public and private sectors generating massive amount of data, from oil and gas company generating seismic images in the north of terabytes and petabytes, to financials, and also in the government and defense with surveillance, healthcares with the clinical records, and so on. Add to that, Internet of Things, or IoT. IoT sensors, simply put, is data collecting devices. So we just keep adding and adding more and more data. In one study shows 50 billion of those connected devices will be in just 2020, which is around the corner. So these devices are becoming more numerous and more powerful, generating more and more data. In one statistics, which is really very interesting, 90% of the data available today was only created last 2 years. It's really massive. So what do you do with this tsunami and huge amount of data? If we use these AI, machine learning, and deep learning technologies, we can unlock the potential of this data, as this data will hold the promise of continuing the human progress. This tsunami of data, as I said earlier, need different than traditional methods and techniques to unlock the potential of this value and increase or continue the human progress. You need a data-driven approach that operates directly on data. And this would AI, machine learning, and deep learning would be ideal for this, because then they can operate in data and without having to explicitly program it. So you don't have to have a developer or software coder to tell it, if you find this condition, then do this. If you don't, then do that. This is implicit programming. So what's AI? So AI, there's no one agreed upon definition for AI, but one that I like very much is it's a purpose-built, non-biological system that can perform a given task and just put 2 lines or maybe 3 lines under a given task and make a decision like a human do. So it tried to mimic how our brain, our human are making decisions. But even with the latest advancement on AI, it's still doing good at one single task. That's why I said, underline the given task. So in contrast with AGI, or artificial general intelligence, imagine thinking machines that can reason, think, and make a decision and learn on its own without having to teach them that. So they can pick up and learn more on their own. So this is AGI. There is a lot of hype out there on AI and AGI, what it can and what cannot do. And the last thing I want to do is to add to more of this hype, right? So just to be clear, we have no clue today how to do AGI, artificial general intelligence. I believe, personally, we are decades, if not centuries away. It could not happen, it may not happen in our lifetime. But instead, we'll be focusing on AI, or sometimes known as narrow AI. The narrow means it's targeted for a specific task, maybe a couple of tasks, but not as AGI. And again, AI is a very broad term, under which there's many different fields. So now I said earlier, rule-based system or rule-based expert system is still available and still valid today, but this is only one field. There's many, many other fields: robotic automatic systems, natural language processing, computer visions, and many, many others fall under AI. But one particular one that really took off in terms of performance and in terms of how accurate it can unlock the potential of the data, which is deep learning, based on something called neural network. Now, I'm trying to oversimplify it here. On average, as a human being, we have 100 billion neurons in our brains, right? And each neuron is connected, again, on average, around to 10,000 neurons. So you can see this massive, huge network of biological neural network, right? And the way we learn as a human at early age, each one of these neurons has to decide if it's going to ping or not. And the way it's make this decision by taking input from the previous neurons. And it will weight these inputs, meaning it will take some notice of some than the other. And if it does exceed certain threshold, it will fire, it will ping, it will turn on, right? So imagine when a small child see a picture of a cat or a real cat in a real world, then some of these neurons inside your brains will fire. Of course, when you see some other pictures or hear another word or read another sentence, different part of your brain will be turned on. So modeling after this behavior, right? Deep neural network, or sometimes called artificial neural networks, to make the distinction between biological and non-biological, is based on similar concepts. So you have what we call different layers, right? So think about the image is an input to that neural network, or artificial neural network, or ANN for short. It goes through these massive layers. It could be tens, thousands, and these connections have to be similar to the neural, biological neural network, has to be adjusted such that it will recognize that feature in the end. So for example, if you give it lots of pictures of cats and lots of pictures of dogs and so on, and you keep tweaking those connections and weights to ultimately recognize all these pictures, only then you would have something called trained model or trained neural network. And this, in many cases, has become the method of choice as the state-of-the-art technique in many different disciplines and areas. Okay? It also become capable on its own to recognize features and recognize face. So this part, this example, facial recognition, is part of computer vision. In simple words, teaching the computer how to see. And what does it recognize in this image? And the beauty about a neural network is, as it progresses to the different layers that we saw earlier, it knows on its own how to extract, how to identify relevant features. So start from the very first layer of very primitive features. This could be horizontal line, vertical line, maybe a part of a curve. And as it progresses through the layers of the network, it will add those into higher order features, if you will. It put the two curves together to make an eye, or a nose, or an ear. And ultimately, at the very, very last end, it will put all these as a one feature, which is called a face. Of course, we're not done yet. If you're doing a facial recognition, then you have to have a few more layers to identify who this face belongs to. But now, for the first time, it's capable, and as the previous speaker mentioned, it's outperforming the human being. In one competition, for ImageNet competition, at I think it's based on Stanford University, 1.2 million images with 10,000 categories. Okay, so it's not only dogs and cats, but different categories. And for the first time in 2014 or 2015, the winning topology, the winning artificial neural network based on deep learning was outperforming what a human in the same data set. And this is just the beginning. Again, higher accuracy is only available because now you have massive amount of data with huge amount of compute power available. Then also the advancement in the computer science, having those architectures that's tailored for specific tasks. So for example, computer vision that we saw an example before is different architecture or different topology than natural language understanding, which is, again, teaching the computer how to listen, what did it hear, and how to translate it from voice to text, or from one language to the other. Okay? So where AI is successful today, we saw the example of computer vision, right? Object detection, image classification, where you have a bunch of images and you try to categorize them in different categories. Computer today, or deep learning based on artificial neural network, has become the standard, has become the method of choice for these type of problems of computer vision. Okay? Natural language processing. So again, translating from when you talk to the chatbot, for example, you put in your voice, and the chatbot has this mechanism based on deep learning to take this voice, translate it to text, understand what it means, and then try to form an answer for that. So this is a very complicated process, right? But today, there is major advancement in this area on NLP, natural language processing, and natural language understanding. And last but not least, Dr. or Professor Andrew Ng, which is a lead researcher in Google and Baidu, and he's co-founder of the online course Coursera. He said once, simply, if the human can do something within 1 second or less, it can be done by AI today or in the very near future. For example, if you have a picture of a cat, how long does it take you to recognize it's a cat? Less than a second. So it can be done today or very near future. As we progress in time, as you have more complex layers, as you have more data, which we already seen that we have, and then the compute power also becomes more powerful and more affordable, we can unlock, we can uncover more complex features. So therefore, we can identify and solve more complex problems. hopefully in the near future, we will find a cure for diseases that were very hard to uncover or to solve before. Another good example would be in health. For example, identifying tumor from MRI images at early stages, or identifying vision-related diseases. So the idea here is not to replace the domain expert or the doctor in this case. The idea is of AI to augment the expert. In this case, give him more information. Maybe he need to take more images or MRI images to identify if this patient has some potentially to have cancer or not. But at the end of the day, it could save lives because the doctor is very busy doing other stuff. So AI can take care of this mundane mundane tasks, and highlight something that the doctor may have missed or radiologist may have missed. Okay. Another example, still in health, when they make medicine, right? So they take these molecules and try to do experiments, chemical experiments with them. And of course, this will be specific to certain disease to cure certain symptoms, right? But they do this experimentation that takes a long time. And with deep learning, now they can narrow down these, at least, options to the molecules that favorably bond together. So not only they will cut in the amount of time, but the amount of resources and money that will be spent to uncover and reach out to the final medicine. Okay. But there is a cost. Deep learning, machine learning is really the state of the art, as we saw earlier, many, many examples, but it does not come for free. There are some challenges, right? So even though there is a lot of data available today, data volume and data quality is important to have the right performance that you're looking after. So by that I mean data could be available in multiple places and could be fragmented and siloed. So how you bring all these data together and form it into a machine-readable format so you can perform this training and later on put it in production. But also the quality of data is very important. It has to be relevant to what you're trying to solve. If the pattern is not in the data, it cannot be found, even though you have the deepest and the biggest neural network. Bias, ethics, and fairness. How do you know that the decision this neural network or this trained model made is wrong or right, is fair or not fair? For example, also adding the bias into the model, sometimes by, unintentionally you can do that. Let me give an example. If the training model has to detect a disease, and let's assume for a minute this disease is more prevalent in women than men, then the gender bias will be baked into the model, whether we want it or not. Okay, so as a human, as a society, we have to understand where this bias is coming from and try to remove it or eliminate it from the data. So this will be very important. Opaque model. Opaque model just simply means it's a black box. We have no idea how this deep neural network, even though it has the highest 97% performance or detection accuracy, we don't know. If you ask him, how did you reach this decision? Today, we have no idea. Why? Because we don't control the logic of building the actual code. Remember I said implicitly programming? Now, if you go back in many, many years, the rule-based techniques, yes, we tell it what to do. We tell it, if you find this condition, do this, otherwise do that. So we can track back and find out why did it make this decision or not. But even with the latest advancement on these techniques, it cannot even come close to the performance of deep neural network. However, there are many, many research studies, and this is a very active area of research, to try to identify what's called explainability. How did it reach to this decision or that? Okay, so that's some advancement as well in there. And the last one is, so of course, there's many, many other challenges, but I put here just the main highlights. Reasoning or empathetic response. So I mentioned earlier the example of the chatbot. So let me give you a very simple example. Somebody has ordered online from Amazon or eBay a gift for his niece. And it came, let's say, 2 days later than what it was supposed to arrive. And because of that, he missed to give it to his niece because his birthday already passed. Now, if you call the customer support and the chatbot answers, so if you explain to him that, the chatbot, doesn't matter how much data it's trained on, it cannot do a response like this. Oh, sorry, I'm sorry about that. You missed your, your gift for your niece, and I hope that she has a good birthday. What can we do to remedy this situation, to retrieve this package or to return this package? It cannot do that. Empathetic response is very, very hard for AI, at least today. So hopefully with more data and more different scenarios, it can get closer to what that. But today is very challenging. So another survey, we ask, what are the most 3 challenges or barrier to adopting AI today? And guess what? 54% highlight the lack of necessary skills. So that's when academia comes into play. That's when you actually prepare the future generation with the right skill sets. It's called data scientist. Now, my son goes to the University of Illinois in Urbana-Champaign, and he's studying psychology. Okay? He's taking a data science class. So there was one saying, and one said, I would quote from Mark Cuban, is one of the pioneers in AI. He said, AI, machine learning, deep learning, if you don't understand it, learn it. Because if you don't, in 3 years, you're going to become a dinosaur. It is going to be involved in different industries. It doesn't, we heard earlier, it's inevitable. It's going to happen. So learn it if you don't have. You don't have to go deep again into the Python code, like I said earlier, but at least to understand what it can and cannot do, and how you implement it, and how you, make it relevant to you. So having this skill set in deep learning and machine learning, it will make you stand out from the crowd. And we just scratch the surface. Okay? There is many different theories untapped that can be leveraged and can be resolved by these technologies. And I conclude with this quote from Francois Chilwell. Don't believe in the short-term hype, but do believe in the long-term vision. It may take a while for AI to be deployed to its true potential, a potential the full extent of which no one has yet dared to dream. But AI is coming, and it will transform our world in a fantastic way. Thank you.
Thank you so much, Mr. Raed, for enlightening us in the field of AI and machine learning. Indeed, we have to train our students on the same, because AI and machine learning, this is the future. And today's students will be tomorrow's leaders.
Yep.
Once again, thank you so much, Mr. Raed, for being here with us today.
You're welcome.
We have a small token of appreciation for you, requesting Professor Dr. Aryan Saha to gift him the same. Now, I guess everyone's still having a great time here, and I'm pretty sure all of us are tech savvy and forever updated on social media. So don't forget to tag us with hashtag BitsPilani Dubai, followed by hashtag Always Ahead and hashtag GISA 2019 while sharing your updates on social media, may it be Instagram, Facebook, Twitter, whatever it is. Hashtag hashtag Bits Dubai, hashtag Always Ahead, and hashtag GISA 2019.